In React, sometimes components can fail and cause errors, disrupting the user experience. Error boundaries provide a way to gracefully handle these errors. Think of them as a safety net that catches JavaScript errors in child components, preventing the entire app from crashing. Here, we have a component that intentionally throws an error. In the real world, this could be due to various reasons like failed API calls or unexpected input. React 18 introduces a new hook called useErrorBoundary, specifically for functional components. Previously, error boundaries were only possible with class components. This hook simplifies error handling in functional components, making it more accessible. To use it, simply import useErrorBoundary from the React Error Boundary package and initialize it in your component. It returns an array with the error object and a function to reset the error state. Now, let's see how we can use this hook to create a basic error boundary. By wrapping the problematic component with a conditional statement, we can display a fallback UI when an error occurs. If an error is caught, the error boundary renders a simple message, "Something went wrong," instead of the component that caused the error. This prevents our entire app from breaking down due to one faulty component. A user-friendly error message can greatly improve the user experience. Let's create a custom fallback component, Error Fallback, which displays a more descriptive error message. When an error is caught, Error Fallback is rendered, showing the specific error message. This way, users are better informed about what went wrong. Error boundaries in React not only catch errors but also provide valuable error information. This information can be used for logging errors or displaying more detailed messages to the user. In this example, we logged the caught error to the console, which can be incredibly helpful for debugging purposes. Error boundaries have their limitations. One common pitfall is not handling asynchronous errors. Error boundaries in React do not catch errors inside asynchronous code directly. In this scene, we demonstrate how to handle such scenarios. By catching asynchronous errors manually and passing them to the reset error function of the useErrorBoundary hook, we ensure that our error boundary can handle these kinds of errors effectively. In some cases, you might want to give users the option to recover from an error, like retrying a failed operation. This is where resetting the error state becomes crucial. Here, we show how to implement a reset mechanism using the reset error function provided by the useErrorBoundary hook. By clicking the Try Again button, the error state is reset, and the component gets a chance to re-render without the error. Error boundaries can be even more powerful when combined with other React hooks. In this example, we integrate useErrorBoundary with useState and useEffect. This allows us to manage complex states and side effects while still handling errors gracefully. It demonstrates how error boundaries can be a part of more sophisticated component logic, handling errors from asynchronous operations like data fetching. When implementing error boundaries, it's important to consider their impact on performance, especially in large applications. Inefficient use can lead to unnecessary re-renders and performance issues. Here, we use the useMemo hook to optimize our error boundary, ensuring that it does not cause any extra re-renders. This is a key practice in maintaining the performance of your React application. Testing is an integral part of development, and this includes testing your error boundaries. Ensuring that they work as expected is crucial. In this scene, we demonstrate how to write a test for our error boundary using React Testing Library. We simulate a scenario where the error boundary is triggered and verify that the correct fallback UI is rendered. Error boundaries aren't just for catching errors. They can be creatively used for other purposes, like feature toggling or managing experimental UI components. Here, we use an error boundary to control the visibility of a feature based on a feature flag. If the feature is disabled, the error boundary throws and catches an error, showing an alternative UI. This showcases the versatility of error boundaries beyond traditional error handling. Let's put everything together in a real-world scenario. In complex applications, you'll often have multiple components with different failure points. Here, we implement an error boundary in a complex component setup. The error boundary wraps around several components, providing a safety layer for the entire section of the app. This real-world example illustrates how error boundaries can be integrated into larger application structures, enhancing stability and user experience. To conclude, remember that error boundaries are a powerful feature in React for handling errors gracefully. We've covered how to set up and use the useErrorBoundary hook, customize fallback UIs, handle different types of errors, and integrate with other hooks. We also discussed performance considerations and testing strategies. A key best practice is to place error boundaries at strategic points in your application, typically high up in the component tree, to catch errors from a wide range of child components. Remember, while error boundaries are essential for handling unexpected errors, they are not a substitute for proper error handling throughout your application.